Okay, so low class, ano? Sorry for the delays of for this recording. Okay, so this is for one. I'm for ano. Sorry for sabi ko nga, delays sa pag-record nito, and I think this one is long overdue. So I would like to apologize to you guys. So again, sabi ng klase nyo, natapos na daw tayo dito sa heat capacity and specific heat wherein we said that the factors influencing the amount of energy absorbed by different system is dependent on the amount of material by mass or by moles, the type of materials, as well as the temperature change. Ano? Wherein we use this formula if we're talking about mass. Now, Q equals to MC delta T. And specifically, this one is MCP delta T or MCB. Depende sa kung ano yung constant. No? So, and in terms naman sa moles, you have Q equals to NCP delta T where N is the number of mole and C is the specific heat in terms of moles. Okay? So, yun yung sa heat capacity and specific heat. So, may binigay tayong example sa libro. We have heating a 24-gram aluminum can raise its temperature by 15 degrees Celsius and we are asked to find the value of Q for the can o kung ilan yung na-absorb na heat ng can. No, kasi nagkaroon siya ng increase in temperature. So, when we look at this problem, yung mga given dito, would be the mass as well as the increase in temperature. Take note that this one is the increase. It's not exactly the temperature itself, ano, but the increment, ano, yung itinaas ng temperature. Now, ito yung tawag dito, ito yung specific na sinasabi natin, yung C. No? So for aluminum, you have yung specific heat ng aluminum is ito, 0.9 joule per gram per Kelvin. No? O joule per gram Kelvin. So, and in terms naman dito, since sabi natin ang Kelvin and Celsius, pareho lang yung increment nilang dalawa. No? So, interchangeable naman. Kung gagamitin mo Kelvin, kung gagamitin mo Celsius, as long as in terms lang siya sa specific heat as well as in terms sa difference in temperature. Okay, so using the formula MC delta T, so latag mo lang yung lahat ng formula na parang direct substitution lang to, and then you will obtain 324 joules. Okay? So, ay, ulit. Ayan. So another example here, we have a block of iron weighing 207 grams absorbs 1.5 kilojoules of heat. What is the change in the temperature of the iron? So, what's the change in temperature? Let's go back to our formula. Q equals to, let's let it natin. Q equals to MC, okay, C delta T. So, kung delta T ang hinahanap natin, manipulating this equation, you now have the change in temperature as equivalent to, wara-wara ang pen ko, as equivalent to Q over MC, wherein sabi natin from the problem, Q is 1.5 kilojoules or 1,500 joules over the mass of 207. Ang hirap naman to. 207 grams and specific heat of iron or ito, that is Fe 0.444. 0.444 joules per gram Kelvin. Or kung sabi ko nga, pwedeng Kelvin, pwede ring Celsius degree. Di ko na bilo. Bilo. Wala. Ayun yan. Anyway, yan. So, as you can observe, calculator na lang to. So, you have 1,500 divided by the quantity 207 times 0.444. So, we will have 16.30. No, 32. Or, yan, the change in temperature is equivalent to 16.32 degree degree Celsius. Ayan. So, pagpasensyaan nyo lang sulat ko, ano, medyo, ano lang, hindi kaaya-aya. So, so kinusal, madali lang naman, ano? Now, you can also determine the heat using moles. No? So here we have the problem. The molar heat capacity of liquid water is 75.3 joules per mole Kelvin. And if 37.5 grams of water is cooled from 42 to 7 degrees Celsius, what is the Q for the water? And here you have already the equation. You have the mass multiplied by the mole per gram or the molar mass of water. Take note again that water, we're talking about H2O, no? Yung molar mass ng hydrogen is 1. 1 gram per mole, no? And yung oxygen naman is nasa 16. So kung dalawa yung hydrogen, so multiply natin to by 2. That's why we have the molar mass of H2O as 1 times 2, 2 plus 16, we have 18 gram per mole. So you have now 18 gram per mole. So multiplying this by the given grams, you convert the, or rather not multiplying, but rather dividing. No, kaya inverse yung nandito. It's not 37.5 times 18, but rather 37.5 divided by 18. Pag divide natin yung mass by the molar mass of water, you obtain the total mole of the substance. Now, kung ang specific heat ng water in terms of mole is 75.3, minumultiply lang natin ito dito. And then, you will obtain, ayan, ito, 5.49 times 10 raised to 3 joules. Now, here, ma-observe natin that the difference in temperature is negative. Kasi yung initial temperature natin is 42, which is mataas, di ba? Mataas yung 42 as compared dun sa final temperature na 7. So therefore, pag bumaba yung temperature, we lose heat. Bumaba yung heat, so therefore, nag-release ng heat yung substance. Okay? So that's why we have 35 joules. Or in terms of an equation, you have the final temperature minus the initial temperature. And in our problem, the final temperature is 7 and the initial temperature is 42. That's why we have 7 minus 42, negative 35. Okay, so I hope malinaw ito. Kung hindi malinaw, i-reply nyo na lang. Okay, let's proceed. Kasi pagdaanan na natin to, but bismillah. Next, you have this problem. If 226 kilojoules of heat increase the temperature of 47 kilograms of copper by 12.5 degrees Celsius, what is the molar heat capacity of the copper? So let's first write given. So you have the heat as 2 to 6. 2 to 6 6 kilojoule. It increased the temperature of 47 kilograms. So the mass is equivalent to 47 kilograms. The increase in temperature, the change in temperature, since this one is already an increase, so wala na tong initial and final temperature. No? So yung increase in temperature is positive 12.5 degree Celsius. And we are asked to determine the molar heat capacity. Find the molar heat capacity of, or let's say C. Okay, so ito lang yung binigay sa atin. In order to solve this problem, now solution, we go back to our equation Q equals to NC delta T. No? NC delta T wherein N can be obtained by multiplying the mass by the molar mass of copper. So, tingnan natin baka may given na ano dito. May binigay na atang um, saan yung copper dito. Ito, may binigay na sa, ay walang, ito, 24.5. So, yun yung molar heat capacity ng copper. But, yung process, is hindi natin alam. So, alamin ko muna yung heat capacity ng, ay rather yung molar mass ng copper. Heats and temperatures. Wala ba dito ano? Uh, Teka lang. So molar mass of copper is 63.55. Okay. Uh, Again, this one is M times the, ano ba yung symbol natin for molar mass? Anyway, that's 63. So 1 mole per 63.546. 63.546. Wara-wara. 5. So hanggang dito ba naman, pati yung ink natin is namang problema ba? 63.546. That is how you determine the N multiplied by C, which is ito yung hinahanap natin, multiplied by the change in temperature na 12.5 degree Celsius. Yung Q is ilan ba ito? 226 kilojoules. So kung kilojoules siya, convert natin sa joules, you have 226 tapos dagdag tayo ng 3 zero. Yung mass, pwede natin siguro ilatag dito yung kung ilan yung mass. You have 47 kilograms, so that is equivalent to 47,000 grams. 47, 1, 2, 3. So yan. So as you can observe, kung multiply lang natin to lahat, maliban doon sa C, syempre wala pa namang value yung C. So you have 47,000 times 12.5 divided by 63.546. Ayan, 9245. So we have here 9245. 9245. Tapos 226 sa kabila. Tapos ito na yung C. So we divide both sides by 9245. 0.9245. So 226, 123 divided by the answer you have. Now, the value of C or the specific heat of copper as 24.44 joule per mole degree Celsius. So that is also equivalent dun sa answer na nakuha natin. Okay? Now let's proceed. Ayan naman, another one. A glass contains 250 grams of water at 78 degrees Celsius. A piece of gold 230 degrees Celsius is placed in the water, and the final temperature reached by the system is 76.9 degrees Celsius. What was the mass of gold? The specific heat of water is 4.184, and that of gold is 0.129 joules. So, ayan, we now have this certain scenario wherein, teka nga, teka lang. Ayan. So, uh, palit lang ako ng application na gamitin dito sa problem. Again, in terms of the problem, sabi dito, we have 250 grams of warm water at 78 degrees Celsius, and naglagay tayo ng gold doon na nasa 2.3 degrees Celsius. No? So, nangyayari, if we have this glass of water, no, may glass of water tayo dyan that has a temperature. Let's say this one has a temperature of, ilan ba yun? 78 degrees Celsius. Teka, naka-record ba ako? Nag-record pa ba? Oh, record ka. Sige. 78. So this one, this glass of water has 78 degrees Celsius. And pag naglagay tayo ng gold dito sa loob, so yan, no? Nandiyan yung tubig, naglagay tayo ng gold that has a temperature of, ilan ba yung temperature? 2.3. So itong gold na to has 2.3 degree Celsius na temperature. And sabi dito, the final temperature, this one is the initial temperature, ano? The final temperature of both the water as well as the gold is at 76.9 degrees Celsius. And binigay din yung specific heat ng water as 4.184. Specific heat ng water is 4.184, and that of gold is 0. Wala yung pen ko. 0.129 joule per gram degree Celsius. Joule per gram degree Celsius. So, ang nangyari dito is nagkaroon ng heat transfer galing dito sa warmer material, which is itong tubig na to. Itong tubig na to, papasok dun sa gold. So kung gold, dapat gold din. Lagyan natin ng parang yellow. Yan. Yan. So kunyari gold. Ay araw, ano kalagay? At naka-araw. So papunta dun sa gold yung init. So therefore, yan, sige. Kung papasok dun sa gold yung init or yung heat, what will happen? So, tataas yung temperature ng gold and bababa ngayon yung kinuhanan mo ng heat, which is ito yung tubig. No? Papasok ngayon yung init dun sa gold. So therefore, kung magbabawas tayo dito ng temperature, tataas yung temperature nung gold nugget. until such time that both the material reach an equilibrium temperature. So, papasok ngayon sa equilibrium temperature ng dalawa. That's why, in terms of thermodynamic systems, no, parang i-isolate natin to. I-isolate natin tong material na to from the universe. Ano kasi in reality, of course, itong tubig na to, magkakaroon pa to ng heat transfer palabas, 'di ba? Magkakaroon pa to ng heat transfer sa labas, sa air, for example. That's why continuous lang yung pag-transfer ng heat from one material to another. That's why ang pag-uusapan lang natin dito is yung dalawang material, which is yung gold at saka yung water. So, going back, going back. So the heat uh, released, heat released by H2O, yung nilabas na init ng H2O is equivalent therefore to the heat na inabsorb by the gold. No? Yung nilabas na init ng tubig is equivalent dun sa na-absorb ng gold. So, therefore, uh, if you have the temperature nito, so, tawag dito, as you can observe sa problem, walang binigay na heat na binilabas ng H2O, no? As well as yung heat na na-absorb ng gold, walang binigay. So, ang babalik lang tayo sa formula natin that Q is equivalent to MC delta T. So, kung yung heat na release kang H2O, kumbaga Q ng H2O is equivalent dun sa Q ng gold. So, therefore, following the same equation, may binigay bang mass? Meron. So we have a mass of water as equivalent to 250 A. Teka lang. 250 grams. And yung gold naman, for the mass of gold, we have, ilan ba yan? We're asked to determine the mass of gold pala. Di natin alam to. Okay, yun pala yung hinahanap natin yung mass of gold. Yung supporting na ha? Ano lang kung one-third ng ako? So, but
Kuya, pinakaharap ko dito.
ha?
Pinakaharap ko sa
Iga? Ay, ito pala.
Kasi isog na lang kanina na para maagi mo na dyan sa TV.
Hindi mo na lang dilipat, Rod. Sorry na.
Oo. Ako kaya nag-design yung ano din wiring ni Kiss sa sentro.
Wala din. Thank you.
Di ba nagagawa sa top speed?
Good eh. Hindi ko alam. Hindi, naka-record, going recording. Yun na yan. Ayan. So, ang hinahanap pala is yung mass ng gold. Ano? So, aalamin natin kung ilan ba tong mass ng gold na to. Of course, meron na tayong equation dito. Meron na tayong solution dito. No? So, ayan. So, latag natin yung mga given. So, MC delta T for the water, as this one is equivalent to MC delta T for the gold. Anyway, ayan. So, mass ng water, we have 250 multiplied by the C, or the specific heat of water as 4.184 joule per gram degree Celsius, and the change in temperature of the water is so the change in temperature is from 78, the initial temperature of 78, papunta ngayon sa final temperature na 76.9. So, based na sa equation natin, gamitin natin muna yung final, which is, ilan ba yun? 76.9 minus yung initial temperature niya na 70. Minus 78. So, this is equivalent to the mass of gold multiplied by the specific heat of gold, which is at of 0.129. Ay, 129 joule per gram degree Celsius multiplied by the change in temperature of gold. Take note that the initial temperature is 2.3 degrees Celsius and the final temperature is the same as what we obtained in the water, which is 76.9. So minus na to sa initial na 2.3. So computing the values of this one, you have 250 times 4.184 times the quantity is 76.9 minus 78. You have negative 1150.6. This is equivalent to 0.129 times the value 76.9 minus 2.3. So we have 9.6234. This is the mass, this is for the gold. So divide natin to 9.6234 divided by 9.6234. You have 1,150.6 divided by the value. You will have the mass of 119. $119.56. So take note na yung heat release is negative. Ano? Negative yung value natin dito. So lagay natin ang negative dito para at least pagdating dito, maging positive na siya. Kasi mag-minus tayo dito ay negative yung tawag dito. Kumbaga palabas yung heat, kumbaga minus ito. So para at least maging positive pa rin yung mass kasi wala namang negative na mass. Take note, ano? Unless na lang difference yan. So 119.56 grams. So, verify natin, baka mali naman tayo. Okay, 119.56, 120 grams na dito. Okay, another problem. A 125 gram sample of cold water and 283 gram sample of hot water are mixed in an insulated thermos bottle and allowed to equilibrate if the initial temperature of the cold water is 3 degrees Celsius and the initial temperature of the hot water is 91 degrees Celsius. What will be the final temperature? So ito naman, pareho tubig yung pinag-uusapan natin. Latag lang muna natin mga given. We have for the cold water. This is equivalent to mass of, ilan ba to? 125 gram. And for the hot water, you have 283. Okay, tapos minekos-mekos daw sa thermos bottle. And we have an initial temperature of, ilan ba to? 3 degrees. 3 degrees Celsius. And dito, yung final temperature dito is, ilan ba to? Or rather, not the final temperature, but the initial temperature naman for the hot water is, ilan ba to? 91. 91 degree Celsius. So, ang hinahanap is what will be the final temperature. So, same manner lang tayo. The heat release, or rather, so parang negative Q of the hot water is equivalent to the heat that is absorbed by the cold water. Now, plugging in the formulas or the equation, you have MC delta T, wherein ang delta T natin, kahit hindi natin ilagay siya as delta T, this is equivalent to the final temperature minus the initial temperature. So take note that this one is for the hot and this one is for the cold. So we have MC, let's say C, multiplied by the specific heat of water multiplied by the value TF minus TI. So take note that the final temperature or tawag dito, or the same, no? And however, we have different initial temperature. Also, the specific heat are the same. So actually, pwede na natin itong i-cancel out. O yung Celsius dito. So plugging in the values, latag natin yung mga values na nandito. You have the mass of hot water as 283. 283 negative. So multiplied by the final temperature, which we don't know yet, minus the initial temperature of the hot water as 91. This is equivalent to the mass of the cold water, which is 125. This is in grams, ano? Multiplied by the final temperature, which we don't know, minus the initial temperature of how much? Initial temperature ng cold water is 3 degrees Celsius. So, ayan. So, as you can observe, pwede na natin itong i-manipulate. Pwedeng i-distribute, no? Distribute na lang natin. No? Kahit anong process ang gusto nyong gamitin, basta tama. No? 283 times 91. So, we have negative 283 TF plus, alam ba to? 257.53. Magiging plus na no kasi negative times negative, positive. This is equivalent to 125 times 3. So, we have 125 TF minus 375. And manipulating this equation wherein lipat na lang siguro natin yung negative dito sa kabila, or rather, ito na lang lipat natin. So we have 125 TF plus 283 TF. This is equivalent to 25753 plus 375. So as you can observe, ang nilipat natin is ito as well as ito. So nilipat natin sa kabila para maging plus siya. Ayun yung isa is nilipat natin sa right side of the equation. Although dito sa ginawa ko parang baliktad rin. Ano? So depende na yan sa inyo kung anong trip ninyo. Ako kasi medyo nasanay na akong ganito na nasa left side yung ano. So 125 plus 283, 408, 408 PF. This is equivalent to 25753 plus 375. Yeah, 26,128. So dividing both sides by 408, divide by 408. The final temperature is equivalent to 64.04 degrees Celsius. So yung final temperature niya is nasa 64. Okay, so verify natin. Tingnan natin yung mga kung realistic naman yung 64. So the initial temperature of the cold water is 3, the hot water is 91. So dapat ang makuha natin na value is in between these two extremes. Kasi ma-equilibrate silang dua, no? Ma-match sinda. Sa wrong temperature, mababa. Sa wrong temperature, yung sa cold water, mataas. So dapat magmi-meet sila somewhere around the middle. No? 64.0. Okay, so okay na siguro yan. Stop ko muna to before we go to calorimetry.